OK， 开始录了。感觉OK, geometrical optics. Okay, geometrical optics is a study of refraction of light under different medium of different refractive index. Okay, so after this chapter, we're going to look at a few things. Okay, so number one is the process called reflection. Okay, reflection. And then under reflection, we're going to look at the process of curved mirror. Okay, curved mirror we have three types. The first one is the spherical. Okay, spherical curved mirror. Number two is a parabolic curved mirror. The third one is the hyperbolic curved mirror. But you only need to know one. Then these two is not in the syllabus. Okay? And then after curved mirror, then we go to refraction. Okay? Refraction. Now under refraction, we're going to look at the next application under refraction is lenses. Okay? Lenses. Now lenses is divided into two categories. We have thin lenses, okay? Thin lens, and then we have thick lens. Okay, thick lens. So thick lens actually the application and the formula used is can be traced back to curved mirror lens or refraction at a surface. And then after that, we have all their lens equation. Okay, and then after that we have lens maker equation. Okay, lens maker equation. So more or less about 6 subchapters. Okay, and then of course under when we study refraction curved mirror lenses, we need to know how to draw ray diagram. Okay? Ray diagram, and that is the most interesting one. Okay, so normally we cannot get an answer most of the time. Okay, okay. So the first one, reflection. So what is reflection? Reflection is a bouncing of light ray from a surface. That surface can be any surface. But surface we divide them into two types. One is a rough surface, and then another one is a smooth surface. So reflection, we look at two types of reflection. One is specular. Okay? Specular reflection. Specular reflection is something that looks like reflection from a mirror. When you look in a mirror, you see gold, right? You see yourself, right? So that is perfect reflection. Specular is also called perfect reflection. Okay? Perfect reflection. So we show by using this diagram. Okay? And let's say there are 3 light rays hit the surface, okay, which is very smooth, like the mirror. And then we have all the light rays like this. Okay, you can see that? Parallel light ray. All their angles are the same. Okay? The angle are all the same. Now, the angle we actually measure from the normal line. Okay? From the normal line, every point of reflection, the reflection has this normal line. So the angle is this angle. Okay? All the angles are the same. So we call this one incident angle. So I. Okay? I. Now, for any type of surfaces, the reflection always follow a rule. One of the rules is that the reflected light ray or the reflected ray will have the same reflected angle. Okay? So that means they will be reflected at the same I value. Okay? So here, this parallel, and this one also. So this is the reflected light, and the angle here is also the same, but we use R instead of I. Reflected, reflected. So what the rule is, I is equal to R. The angle will be the same. So this light ray we call the incident, okay, ray. And this one is reflected ray. Okay, reflected ray. Now, that is rule number one. And rule number two is all the line, the incident light ray, the reflected light ray, and the normal light. Okay, so our incident ray, reflected ray, and normal light are all on the same plane. Okay, on the same plane. 不是飞机啊，是那个表面。Okay, on the same plane. For example, there is a mirror like this. For example, there is a mirror. Okay, this is our mirror. So you use a laser pointer, shine like this. Definitely, your common sense theory will be reflected to that direction, right? It's not going to go like this and then bounce down. Something is wrong somewhere already. So the rules that they follow is called the rules or the law of reflection. Okay? It applies to any surfaces, smooth and also rough. Okay, that's the first one. Now we look at the second one is what we call the diffuse, okay? The diffuse reflection. Okay? Diffuse reflection. Diffuse means when light enters, it spread to some other direction. Don't follow like this. So now our diffuse is because the surface is rough. Even though we assume like it is quite smooth. For example, the table surface when you touch is actually quite smooth to your fingers. But actually if you use microscope and last like 100 times, then you start to see there are Everest mountain and then there are Mariana Trench everywhere. So they are actually quite rough. And now let's assume again, we have the same light ray, okay, hit the surface at different position. Okay? Now this light ray, let's say start like this. And then here. And this one here. Okay? So this is our incident ray. Now we draw our normal line again. You have to know the normal line is always 90 degrees with the surface, so it's quite difficult to draw the line in this case. So in this case, because the surface locked to that line, so our normal line will be here. Okay, something like this. Now, the direction is different because of your normal line. Remember that it always has to follow the normal line. This one here, the normal line is like that. See, definitely different direction. This one, the normal line is here. So these are all normal line. 90 degrees with the surface here, surface here, surface here. So what is your angle of incident? So now we have different angle of incident, right? So the first one here, this one is I1, okay? And this one is now I2. And this one here will be I3. They are all different. But according to the law of reflection, your R, S, and I must be the same. So look at the first one. It must have the same angle like this, right? So we have to shift it. So more or less like this. Now the problem is in this case, it reflects and then go to another surface, right? So what happens? You draw another normal line. Now this time it's going to reflect almost at the same angle like that. That is our third reflected ray. If we call this one 1, 2, 3, this is number 3. This one we can also give number 1, 2, 3. This is 3, 2, 1. Okay, now next light ray. This light ray are more simple. So the angle here must be all the same. Now reflected to this direction. This is number 2. I use prime. And then this one should be in this direction. here. So now they are not parallel at all. Now it seems like a single light source come towards the surface, they are spread out at different angles. This process is called diffuse. Okay? Diffuse. There are certain type of diffuse that is not based on reflection. Have you seen a type of glass? Like this one, we know that the light pass through directly, right? When people stand outside, they can see them exactly, and you know who they are. There is a type of office glass that are diffuse. You know someone is out there, but you don't know who, right? You can see there are people moving. Like for example, your school office glass, like that. So that is called diffuse glass. Now how it works? When light pass through normal glass, it goes straight. But when light pass through diffuse glass, the light spread out. So that's why you cannot determine who is there, but you know someone is there. Then you know someone is there. Alright, so this one, they still follow the rules. This is I1. This one, just now that one there. This one is I3. And this one here is I2. Now, locally, that means at that particular point, they still follow the law of reflection. But generally, they are not. Generally, light comes here, they spread out, so they don't follow. But when you trace back to every individual point, they still follow the same rules. Okay? So that is diffuse reflection. Okay? So we will concentrate more on this one. Perfect reflection or specular reflection, because it is important to use mirror to form proper image. You don't want to form an image that is diffuse. Imagine that you have a space astronomical telescope, you look at the moon is diffuse. What's the purpose? What are you looking at? Might as well look at the snail on the floor. Okay? It makes no difference. So we need something very clear. So to make sure that you get good specular reflection, you have to make sure that the surface of the mirror is like perfect up to nanometer scale. Do we have the technology? Definitely not many countries can produce that. And not many company in the world can do that. Okay? And that is called mirror polishing. Okay? So mirror polishing is a highly secretive process. Normally they don't tell you how to do it. Okay? So whoever can do that, they're going to make a lot of money. Okay? James Webb telescope is just up there. How much does that cost? You're talking about billions. How many years? 10 years to build that telescope? And now it's operating, okay, to tell us what is going to happen next. Right? Okay, so the first application for reflection is of course mirror. So we have number 2, mirror. We have 2 types. Flat mirror or plane mirror. Okay, plane mirror. So plane mirror is a mirror that you always use to look at your handsome face. So we are going to use this to show how do we draw, okay, the image form. Okay, when you have a plane mirror in front of you. When I draw a figure like this, meaning that if you see from the left hand side, then you can see yourself. If you go there, what you see is only shaded area is actually nothing. Okay? So now the mirror is 2 sides, right? Okay? Mirror is 2 sides. We are not talking about mirror glass. We are not talking about, we're talking about normal mirror, one-sided reflection. Another mirror, they can coat different things on the surface. When you see here, you can see your own reflection, but when you see other side, you can see through. That is normally what the police interrogation room, right? Okay? They can see how you react, but you cannot see them, but you know they are behind it. Right? So now we have a human being here. Okay, this is Lauren here. Short is good actually. Okay, go on. Okay, so let's assume your distance here is d. Okay? And and this is the top of your head. Okay, so the top of the head. 头发已经梳好了，整齐了，已经被压下去了。对，这样是不是你家没梳的？没有。Okay, now to draw the image, we need to know two things: the lowest point and the highest point, so that we can find your middle point. What's your middle point? If I use a ruler here for measurement, your middle point this is 19, so right? Here. That is your middle point. Somewhere here. 10.5. Very good. Oh, sorry, that one is not 0. 19.5. 19.5, so we have 9.5 here, okay. Now, this is a middle point. That is your middle point. You need to trace this up to the mirror. Okay. Now, how can your eye see that? Yeah, how can your eye see that? Your eye see that is because the light reflected from your feet, from the mirror, enter your eyes. Okay, we assume the eye is quite high in your forehead. Okay, now? Alright. And these two angles must be the same. The I and the R will be the same because they are based on the law of reflection. But our brain actually manipulate that situation and tell us that, or told us long time before, we evolved to something that looks like this. We assume the light is in a rectilinear process, so we always create an image in our mind that it is actually inside the mirror. Okay? So this phenomenon is called virtual image formation. You form a virtual image, that image actually not there. If you go behind the mirror, that will not there. For someone that have no knowledge about the concept of reflection, for example, animal, you show them mirror, they're excited, right? They thought there's a partner to play with already, or they are enemy there. So they react, they also react, so they even getting more angry than that. And some dogs or cats even go behind the mirror to look for that guy. Okay? So this is for human, we know that is not happening. Okay? So now this is the location of your foot. Now next one is your head. Okay? Your head. So now between your eyes and that head, you must find a middle point so that you can draw the reflection of the light from the top of your head, which is the last hair that you have, and then enter your eyes. And now you actually see that your head is somewhere here. Okay? And then this is the top of your head, this is your foot, so this is where your image lies. 每次我们看到自己比较瘦，对不对？Something like that. Theoretically, if the mirror is thin enough, this D prime is equal to D. Exactly the same. Okay. So that one is how. For every part of the body, you can actually form that. But to see your whole body, actually you don't need such a big mirror. You need half of the size of the mirror. Okay? You need half, and the top. Okay? The top of the mirror, okay, must be at the top of your head. And the length of the mirror is about half the height that you have. If you are like 2 meters, you need a mirror of 1 meter. Put at that height, you can see your whole body already, no matter where you go. 只是越远就看越小了，哎，可是不能够太靠近了，太靠近你看不到了，因为这个很大。是这个原因吗？不是。Theoretically, your eyes can't even touch the mirror. Okay? So there is a further limit, there is a close limit. Okay? We call the proximity limit. Okay? So that one is plane mirror. Okay? 来，还要看，不是 已经有录起来了。
录的话还要接每一个找一下吧。
Okay, so this is an object, and this is the image, and this is called the virtual image. It's only formed in our brain. Okay? Okay, next. Next one is curve mirror. So curve mirror need to use this. Okay, next one is our curve mirror. Okay, curve mirror. So our curve mirror will be spherical curve mirror. Spherical means that mirror surface is actually part of a sphere. Okay, part of a sphere. So we can actually use a compass to draw that surfaces. Now we have two types. Okay. One type, we always assume the light coming from the left hand side. Okay. Number one. And this is number two. Number two. So when I draw that line and compare to this one is the first time. This is called concave mirror. Okay. The light up here reflected back to the left hand side. Same thing for this one also. Number two, this one is called the convex mirror. Okay? So don't get confused with the mirror and the lens. The characteristic of the concave mirror is the same as the convex lens. And this one, convex mirror, is the same as concave lens. Okay? So 不要倒转来，每次会做错的东西。Alright, now. This one is a type of mirror that we have. So you see, no matter where you cut the mirror, here or even here, that part of the surface that reflects the light is always part of that circle. It's a circular circle. Why they call it spherical? Because if you want to form a mirror, you can actually start by making a big glass ball, perfectly filled. Okay? And then cut here. Now, that one is a curved mirror. You just need to polish one side with aluminum or silver to make it reflective. That one can be either concave mirror or convex mirror. But of course, we don't purposely go and make one sphere and then cut. Okay? Actually, we cut into a piece of glass or mold it, and then we modify, soften it, and then we put the epoxy on. Alright? Okay, now, first we look at physical property of curved mirror. Okay? Physical property of curved mirror. We start with concave mirror first. When we draw light ray passing through them, there are a few things that we must know the name of. Now, this one is a concave. Okay? Now, the point I use to draw the surface of the mirror, this one is called the C point. C is called the center of curvature. The further the C, the different is the curvature. Okay? Now, the distance, this point here, this line that cuts through the center of the mirror passing through C, this line is called principal axis. Okay? Principal axis, and the mirror that cuts through the principal axis, we call this point the vertex point B. Okay? Vertex of the mirror. Okay? Vertex of the mirror. Now the distance from here to that vertex CV point, this is called R. That is how far the distance between the sharp point of the compass and the pen. Okay? So that is a radius of curvature. Okay? Radius of curvature. Now, radius of curvature, you can also draw somewhere here, like this. This is the radius of curvature. Now, somewhere in between the C and the V, midway between the C and the V, from here to here, let's say this one, this is called the F. Okay? So the F, this one is the focus point. Okay? Focus point. Okay? Focus point. And the distance from F to V, this one have a small symbol F. We call that one the focal length. Okay, focal length. In Chinese, the focus is called 焦点. Okay, focus point 焦点咯。这个距离叫做焦距。Okay, 焦距，焦点的距离，焦距。Okay. So that is basically what we have here. Okay. Now, if you come to the opposite sense of the convex mirror, when this one go to opposite sense, your C point is on the other side. Okay? So that one is the second one. So we draw that second one and we call it differently. There is a special name for it, even though we can use the same radius. Okay, this is a C, halfway is a F, this is a B. Okay, and then we have radius R here. This is a radius R. So this length here is F. Actually, this length is also F. Same thing because it is halfway. So all refer to the same one, except the definition for their value will be different. For example, concave mirror. Okay, for concave mirror, this value is positive. This one is also positive, and because this one positive, this one is positive. But for convex mirror, the C is defined to be negative, thus your R is negative, and because of that, your F is a negative value. So that one is the difference between concave and convex mirror. Okay? But this one is the easiest to solve problem. Because whenever you put an object in front of a convex mirror, there's only one outcome. Okay? It's always virtual. It's always virtual. Right? 是哦，
还是你要入镜也可以。
哎，有一个恐怖的地方，
有一个很会有点。
哦。Okay, next one. Ray diagram. Ray diagram for both of them, but we start with the concave mirror. Ray diagram, first one, concave mirror. And for concave mirror, we have three types. Three. We're going to put the object far away from the C value, just from the C point. Where your F, first one is, the F is larger than the distance between C and B. Okay? Or larger than R. Okay? Sorry, the distance is U. Is larger than 2m. That one is better. So we start here. There are some techniques that you have to remember because if the drawing that you are asked to draw is like too short or too long, you might not get a proper image. Okay? You might not get a proper image. So now we assume our C point is here. Okay? That's our C point. And we're going to use our C point to draw our surface of the mirror. Now this one has to be actually quite accurate. Here I use 10. There is about 10. Okay. So that means it is 10 inches. Okay. So I'm going to fix this one at 10 inches already. That is the back of the mirror. And this is C. So halfway here, this one is the focus point. Okay, focus point. And this is a B. Now, let's say we put object distance that is more than 2f, is f, more than 2f, let's say we put somewhere here. Maybe here. Now, the object is about this size. This is the location of the object. And the distance O to B is called U. Okay? OB is U. Yeah? Now, ray diagram, you have 3 lines. 2 lines to find the location of the image. The third line is to make confirmation of that. First line is always parallel with the principal axis. Any light ray that is parallel with the principal axis will be focused to the focus point. Okay, will be reflected through the focus point. So we call this one 1. The second light ray is a light ray that passes through the center of curvature, C. Any light ray that passes through the center of curvature does not change direction. It goes straight in. Because it hit the mirror at 90 degrees, here it reflected back opposite direction. Okay? So 2 and 4, because here is 90 degrees and pass through C. So this one is number 2. So actually we already know the image is here. Okay? This is the location of the image. Okay? I. Okay? I. Now, third line is to confirm that our drawing actually correct. Sometimes third line is a problem. Okay? Third line is a problem because maybe the object is too big or too near to it. You started to form the third line far away from the actually intersection point. So we draw the third one. The third line is the opposite of line number 1. Number 1 is parallel with the line and then to focus point. Number 3 is you go to the focus point first. So the effect is opposite. It should be parallel. Okay? So this one is number 3. So parallel. So you see, when you draw parallelly, so it actually gets through the same point here. So this is number 3. See, so that is our first drawing when your object is placed far away or larger than 2f value. Now we're going to look at the characteristic of the image form. Number 1, if you use that curved mirror to face the sun, and then you look for use a piece of paper or you can use your hand actually, face the sun and then use your hand to find the image, and then you find the sharpest image. How do you feel with your hand? You feel hot, right? Well, is that reality or virtual? That is reality, right? So that one is a real image. Okay? That is a real image. Okay, number 1, real image. Number 2, inverted. Okay? Sometimes students will use upside down. No, don't use upside down. Something that is like this, if I put my object here, your image is going to be here, right? So how do you call that? It's not upside down, right? So don't use the word upside down, called inverted. Inverted, I mean, it is in the opposite direction compared to the original object. Okay? So this one is upside down compared to this one. Okay? So we call it inverted. One more. You look at the size, diminish. Okay? Diminish. Don't use smaller. It is diminished. Okay? number 2. Same drawing.
画这个的时候，它一定要经过一个 F， 一个经过 C
3条线啊。
如果只画2条的话，一定是一个 F 一个 C。还是2个都是 F。不用画。
这样子，不用画第3条啊。
没有，如果只画2条线的话，一定要一个经过那个center curvature， 一个经过 focus。
啊，它的 reflected 的一定要经过 focus。你画第3条线，它也是其中1条线经过 focus。
第2条，第1条经过 focus， 第2条需要经过 focus 吗？还是经过那个 center curvature？
你在讲什么？
因为你刚才不是画3条，
对。
第2条是你是画它经过那个 center curvature 吗？
啊，对。第3条是经过 focus， 然后反射回去那个 intersection point。
如果只画2条的话，
哪2条线？
第1跟第2条。
第1跟第2。其实不够好的，
对，
弄出点了。
第1跟第3条
1、2、3，1、2、3。Because you know your line number 2 show correct one. You cannot get your line number 2 wrong because symmetry is symmetry, geometry is geometry. That's it. But the line number 1 and number 2 actually depends very much on how far are you from the principal axis. That's why normally we don't use object that is very large. Okay? Later I show you an example. What happens when you use the same lens or same mirror here? Your object is huge. Okay? We show you this one. See what happens when you use a huge image? Exactly the same system. You are going to get a problem to get the things to the same intersection point. Same mirror, exactly. Okay? But now the object is huge. So this is a C, this is halfway here, this is a F, this is a B. Now I use this one, big like that. Object, okay? You see whether your line number 3 can be the same or not. First, go to focus point, right? That's number 1. Perfect, you got already correct. Now, second one, okay, that's not a problem. We can actually extend the mirror even to accommodate the line that we want. Okay? Here, bounce back right? No problem. Number 2, number 1. Now, how do you think about it? You know the image is here. That is your image I. Now, what happened then? Here. Now, draw a parallel line. Oh, getting further and further. Okay, getting further and further. It does not intersect. That's a problem. If you increase your image object further, this line is going to go further and further away. That's why when we use diagram, ray diagram method to find what we call that the image position or the size of the image and so on, normally we have a problem if the radius of the mirror is small compared to the size of the object. That's why we have approximation. To use this method correctly or efficiently or accurately, we have to actually make sure that all these lines are near to the principal axis. Okay? Why? The reason is this one. Okay? You draw one big mirror. Okay? So that mirror has a C point here, and roughly we have a focus point in the middle. Somewhere here. Now let's say we have parallel light ray starting from the center. Okay? Parallel ray, and then here we have, down below here also we have. Okay? And then we have some other up here, down here also. Some lines, some parallel light rays are getting further and further away. Initially, all the lines are parallel. Well, theoretically, you will see that, okay, all of them will actually reflected and pass through the focus point. It's only correct for light ray that is near to our principal axis. Okay, our principal axis, for example, this one. Okay, it will be focused here. Okay, and this one also. This one is correct. And even some line that is close. one definitely will be passing through the F point. Something like this. Okay? No problem with them. Okay? No problem with them. Yes. So this is what happens for line that is close. But when you go to line that is getting further and further away, for example this one, they might be focusing nearer to it. Now see the problem, they don't focus at the F point anymore. They focus nearer to it. And this one, which is at the same distance, this one is going to focus at this point. And then this one is focusing somewhere in the middle. This is why you're going to have a headache. Why? Why this one is a headache? Now you see the same mirror for object that size, okay, let's say that size, the one that near to it is focused exactly at the focus point. But the one getting further and further or near the edge of the mirror, they are focused nearer to the mirror rather than the actual F point. So that means they are not focused. They are not focused. So when you put something here to look at the image, the center of the image is clear, but the rim of the image is blurred. 就好像你拿一个放大镜子，你放大一个 object， 你会看到中间很清楚，可是旁边那些开始蒙掉了，因为你的那个放大镜可能太远了，太远了。就好像你拿那个玻璃弹珠，透明的，你看东西一下，最好是包着咯，你这样扫过，中间是很清楚的，旁边就完蛋了。It is the same concept actually. So that's why we don't want the object size to be too big. Okay, is there any limit? Well, we are not sure if there is any limit, but normally we try to get ratio of 1 to 10. If this one is 10 centimeter, we try to limit the object size to about 1 centimeter. Okay, 1 to 10 or 10%, and 10%, so that you get an accurate, not to say accurate, up to a tolerable error. Okay, up to a tolerable error. Nothing is accurate actually in physics. Okay, there always some error, but as long as the contrast, the clarity of the image is acceptable, then okay. But if you talk about James Webb telescope, Hubble telescope, that is actually not acceptable. Okay, so that's why the mirror are actually quite flat, very flat mirror, but the curvature is a little bit on it. The purpose is to have a very long focus point, so that they can actually enlarge the image to the maximum. But James Webb also have a limitation. Nothing has no limitation. Okay. Okay. So this one is what we call blurring image. Okay, blurring image. Right. So this one also has some problem here. Not all lines coincide. Okay, not all lines coincide.
Yeah.
Okay. Next. Drawing again, but now is the second one where our U value, forgot to tell you, the image distance from V is called V. This is small v, this is big V, vertex. Now our U will be larger than F but smaller than 2F distance. That means it's in between the C and the F. Yeah. 10 inches or so. FC, there's a B. Now object we put it here. Now we are careful. We put the object is small, okay, so that we don't want to meet the problem like we draw the blurring image just now. Okay, now the line, parallel line. Okay, go to the mirror, reflected through the focus point. That is number one. Number two, now how? They are always like coming from here, there will be one light passing through C and passing through the tip of the arrow, like that. So this one, this is how we draw. And normally this one is a dotted line, but because okay, this one hit the mirror at 90 degrees, so definitely it's going to reflect at 90 degrees also. That hit. Okay? So that is our second one. Okay? The second one, and this is our first one. So now we know already this is actually the location of our image I. And we are still worried whether we can get the same intersection point for line number 3. This one here. Okay? This one here. So here. That is the line. Okay, so actually it's not really accurate, right? But still. Okay, so shall we see? 也是可以。从我角度看是平的。Okay, so if now this one is even more serious because it's getting nearer to the mirror, right? So when get nearer to the mirror, remember the problem just now is spread out a little bit the focus point. There is a focal range. So if you put it nearer, if you draw slightly bigger, definitely the line number 3 is going to go down most of the time. So when you draw that, that's why you normally have to sketch first before you submit the final answer. Now come to the characteristic of the image. What's the characteristic? Number 1, this is still real. It's still real, but not as hot as the sun just now. Right? Real. This is a bit real. Cannot still real. Now inverted. Yeah, inverted, but now is enlarged. Okay, enlarged. Okay, enlarged. Last one is the most interesting one. Don't use the word magnify. Enlarge is the best word. Enlarge. Okay. Why so beautiful?
老师啊，没有magnify。
我呢？
没有我们学校。
有出咩？啊，我记得就那个才华第一分，
什么东西？
给你得到他。
哦，是吧？你在耍吗？Okay, now our U is less than 10. Yeah, less than 10. In between, we also have, like for example, less than 10, this one between F and 2F. So it can be U equal to F, and also like larger than F, 2F, and between F and 2F, it can be U at 2F. Those are the special conditions. So our condition here will be less than F. So for less than F, our mirror will go a little bit to the left hand side. C point, F, C, B, and then object is somewhere here. So draw smaller object. Same story. Line parallel. Okay. Parallel line. Go to focus point. Number 1. Okay. And then same thing. Go to here. This one here. Okay. Light come from here. Hit the mirror. Bounce back. Now we have a problem here because the light does not converge on the left hand side. Right? So we know that it does not converge here. Theoretically, it's more or less like a mirror condition. Okay? The plane mirror condition, if we extend the light ray back to the mirror, behind the mirror, we are supposed to get the intersection point behind it. Okay, so that is the intersection point, and this is our image location. And since this image is behind the mirror, so this image is called the virtual image. Okay? This is the virtual image. Right? Right. Now, how to draw the third line? Same thing here. Use this method. 这样画上去。 light ray here, and it's supposed to reflect. 这个不真的是，所以不要画了。因为这个 object too big, object too big already. So object supposed to be small. Okay, so if you draw that line, theoretically, it get reflected away, right? So it get reflected away, it should trace back to the same point here. Okay? So that is your third one. Characteristic. Number one, this is virtual. Okay. Number two, this one is upright. And number three, this is definitely enlarged. Okay, enlarged. Okay. Okay, so that is our concave mirror. Which one? Next one, convex mirror. There's only one drawing. Convex mirror. Okay, there's your C. B is left is here, this is your B. Let's say object is here. Object distance U. Okay, light ray. Same like concave mirror. Parallel first. Okay, parallel. And then reflected away. Seems like the light ray is coming from the focus point. Light ray number one. Number two is a light ray goes straight to the center of curvature behind the mirror. Okay, keep here at 90 degrees and then bounces back, but we draw this line to indicate what direction we are drawing at. Okay, number two. So this one is good enough. The third one, okay, the third one is the point going to the focus point. Okay, the light going to the focus point. But the light is reflected parallel with the principal axis. And if you trace the light back, you're supposed to meet at the same point. Okay? And this is our image location. Okay? So for convex mirror, there's only one outcome. No matter where you put the object near or far, the characteristic is always virtual. And upright. And number three, DVDs. Okay, this outcome is the easiest to remember. Okay? Right. Any question?
Concave mirror 不是还有 infinity concave 和 infinity 不然
Yes, concave you can form image at infinity if you put your object at focus point. At focus point.
virtual 是讲看不到。
Virtual actually you cannot form the image on any metal surface. Metal. It can be like liquid surface, milk surface, coffee surface, whiteboard, any surface. Any surface physical you cannot form it. It's just inside your mind.
那mirror 自己的话就可以了。
Mirror.
我讲过，
我有没有好？
我也是这样，这样
啊，回去照镜这个问题。Now, as long as it's virtual, actually we see that actually the image formation in our mind because of the light ray divergence. Now, let's say I put my eyes here, right? So this light ray does not concentrate here, but when the light ray enter my eyes, it actually there are certain direction that enter my retina, right? And because of that, my mind can actually sense the direction of the light just like vector. Okay? So when it form up like that, another one here, so my mind will define that, oh, the light ray coming from here. That is how our brain function, at least physically. Biologically, don't ask me, ask the bio teacher. Okay? Now, so that's why we have virtual image. Actually, as long as you have eyes, like animal, they're supposed to actually see the same thing like that. That's why they can see their own image in the mirror. But how they react to that is through experiences and also understanding. Like for example, small baby, the first time you let them see an image of themselves, they're actually laughing. Because and before that they have no, I don't think this thing passed down through DNA. They pass down through DNA is for you how to learn, how to acknowledge those things only, right? So to understand that, we must first have a perception of something like knowledge about light ray reflection and so on. But that one is human. Animal, I have no understanding about that because I never been born an animal before. Few thousand cycles before maybe. Are you? You're not sure. 佛教都讲是几千轮回，变成人类，然后做一点坏事，又倒回去变蚊子。世界就讲了轮回。Okay, now those are the curve mirror and so on. Now we look at what are the formula used to calculate this to relate the relationship between the F, the U, and the V. First, we have this Miller's equation. Miller's equation is actually the same as the length equation. And I don't derive this formula. We're going to look at a lot of geometry for them. 1 over U plus 1 over V is equal to 1 over F. But we know that the F distance is half of the R distance. So this one is also equal to 1 over half R or equal to 2 over R. So we have two equations that we can use to relate the U, V, and F and R. Okay? That is equation 1 and 2. But this one only for mirror. Okay? For mirror. Alright? Okay? Okay, next one. Once I wrap this up, next one is reflection. That is the third one already.
就是你不要讲那个 special case，
Special case.
那个比如 U 等于 F， U 等于2F， U 等于什么？
要讲那个啊？
你不知道在讲啊？
老师乱说话。
Special case.
那你说一张多少钱啊？这个我没接中话。
Okay, special case. Our that one special case is special case 1. That one is when your U is equal to 2F. Right? Just now we have further than 2F, and then between F and 2F, so somewhere in between is equal to 2F. This one is a special case number 1. The reason is your image is going to be at the same location as your object. Okay? If we draw it correctly. Okay? If we draw it accurately. But we can adjust a little bit, so don't worry. 考试会不会 pass 的想象？听得懂吗？
没有听到，你只听到什么 pass？
SPF 可以吗 ？SPF 还有
This is a F distance, so we put an object here. Now to be smart, we draw an object about this size. Okay, so this is the object. Now we draw the line. First one, parallel. Go to focus point. Okay, so this one is number 1, and then number 2, where's your C? Go C, go C, you go to the third line. Here,
如果真的要画 C 可以画直的一条。
C, okay. somewhere here that we can just so that we are doing it. See, that is number 2. Now, according to theory, the answer is exactly here, right? Or not? Straight. Who said not straight? Okay. So the image is characteristic will be like this. The characteristic number 1 is still real. Number 2 is inverted, same like before. And then number 3, this one is same size. Okay, same size. Alright. Okay, that one is for special case number 1. Now, special case number 2. There's a C point. If you want to run away. Okay. In the middle. Oh, I forgot the length. The compass point. This one is moving. Okay, the F. Now our object is here. You put the object here. This is the object, and near to the mirror. Now, so we have first one. We have light ray parallel, and then go to focus point. Okay, focus point, and then that's number 1. Number 2. Here, you look at the C point and your okay, the light ray come from here, go 90 degrees, go back, parallel. Okay, number 1 and number 2 parallel to each other, so they won't meet. Your image only form in the infinity. Now, there are certain applications when you form the image at infinity, especially telescope and microscope. Sometimes when we build the telescope and the microscope, you want to get the maximum magnification. Yes, you can maximize it, but when you look at that image, you feel very stressed because you want to bring it as near as possible to you, and you have to stretch your eye looking at that. Imagine one whole night you look at certain star, simply you want to enlarge. Next morning you realize your eye was enlarged because you stress up your eye. So to make it more comfortable, you form the image, yes, at the average magnification, but it forms at infinity. So it seems like you're looking at something naturally. Your eyes don't have to actually focus at the near point of your eyes. That one is for the purpose of more relaxed viewing purpose. Okay? More relaxed viewing purpose. From why you learn it, right? Remember your microscope and telescope. Okay? Okay, so image characteristic, is it real? Yes, it is real. As long as the same size as the object. Number 2 is inverted, right? This one is definitely inverted. And then number 3, infinity. Okay? The size is infinity. Or you can actually say larger than the original object. Okay, next one, reflection. That is refraction. Okay. Refraction happens, okay? It happens when light rays, propagate from one medium to another medium of different optical density. Optical density is another word for example, like this, we have two different materials. Okay. This is like the simplest one. We can actually choose water and glass. Okay. So we still need the same normal light. So our light ray, let's say, start from water. We know that glass is optically denser than water. So if it is denser, the light ray actually slow down. And that is what happened. That process or the bending of light at the interface between the two media is called refraction. It's called refraction. So oppositely, if you have light moving from a denser material, okay, to less dense material, let's say from water to air. Okay, from water to air, you sink to the bottom of the lake and then shine a laser pointer up. You're going to get the opposite effect. From water, the light ray moves slower. When enter air, it becomes faster. As long as you are faster, you are always moving away from your normal light. That process is also called refraction. Okay? So in your form 5 condition is your refraction, the formula you use, which is called the Snell law. Actually, you use it for a condition which is only from less than to denser. Denser to less than, you cannot use the equation that you learned last time. So now we're going to learn a more general concept about refraction. Okay? Now is the Snell law. Okay? So Snell law, we need to have two medium. We call this medium 1. This is medium 2. Okay? And then you're going to do some experiment. Okay? We're going to do some experiment. This is a normal line. Okay? Then this is the light ray we're going to use, and this is the angle, incident angle. And then there will be a changes in the angle when it comes into the second medium. Let's say this is denser optically than that one. This is what you get, reflected angle. Reflected angle. Now let's say you have a few values of I that you can actually adjust. Now you list down the angle and measure the angle up. This is an experiment that we are doing. Okay? So I and R. So have a few values. And after that, you calculate the sine I, and then after that, you also calculate the sine R. And then you plot a graph of sine I over sine R. Okay? Sine I over sine R. You're going to get a straight line. Okay? You're going to get a straight line. That is from Snell. Okay? Experiment. But sounds like 30 seconds already finished experiment, right? Okay, and also we make conclusion, they are straight line. So straight line means what conclusion? They are directly proportional. From this condition, our sine I is directly proportional to sine R. Now, when it is directly proportional, when we form equation, there is a constant K in front, right? So that constant K is called the refractive index. Okay? K is the refractive indexes, okay? Index. But it's not that simple. Okay? It is not that simple. This one is a refractive index of the second medium relative to the first medium. Refractive index of first medium to relative of first medium relative to sorry. Hey. Assalamualaikum. Okay. the first. So that means the K is not as simple as we think. The K is something like this. The value called the refractive index of number 2 related to first. Okay? So if we put that one in, we're going to get sine I equal to N2 over N1 and sine R. And then we have N1 sine I equal to N2 sine R. But I is an angle at first medium. So N1 is equal to sine theta 1. Okay? We put angle theta relative 1, 1, and this N2 sine theta 2. Okay? So that is our sine Snell law. Okay? Snell law. Right? So that is a formula that we can use vice versa in any direction. Light to denser or denser to light, no problem at all. Okay? So that's the Snell law. That is a more perfect law compared to your stupid conformal law that you learn. Okay? Yes, have to stop the recording for a while.
我记得我学的是这个。
这可以 pause